example 2, we have this question. We give the two complex numbers defined below. We have z1 defined as -1 minus I, and z2 defined as half plus I root 3 on 2. Now we begin with question 1. It says determine the modulus and the argument of each of the complex numbers z1 and z2. So number 1, determining the modulus and argument of z1 and z2. So we'll begin with z1. Let me underline this. For z1, I need the modulus of z1 represented like this. It is equal to, remember, z1 is -1 minus I. So the modulus of z1 is -1 squared plus -1 squared. Then I'll take the square root of that. I'll be left that the modulus of z1 is going to be the square root of 2. What about z2? Z2, the modulus of z2 is going to be equal to the square root of 1 on 2, all this squared, plus root 3 on 2, this again squared. So when I find the modulus here, I'm going to have 1. So the modulus of z1 is root 2 and the modulus of z2 is 1. Now I'm going to proceed with their argument. I'm going to proceed with the argument of z1, which is going to be I am going to identify the quadrant. Now for z1, the real part is negative and the imaginary part is negative. So this means that we are in the third quadrant. And since we're in the third quadrant, the argument of a complex number located in the third quadrant is given as pi plus the tan inverse of 1 over 1. I forgot what the sign is. So if I do this, I'm going to have that the argument of z1 is equal to pi on 4. What about the argument of z2? The argument of z2, when I do the same thing, I have it as pi on 3. So now that's all for question number 1. Let me proceed to question 2, which says deduce. Question 2 says deduce the modulus and argument of z1 on z2. So the complex number z1 divided by z2, I need its modulus. By property, it's the same as the modulus of z1 divided by the modulus of z2. The modulus of z1 was root 2. The modulus of z2 was 1. So it means the modulus of this ratio is going to be root 2. What about the argument? The argument of z1 on z2 is going to be equal to the argument of z1 minus the argument of z2. So this, I'm going to take the argument of z1. The argument of z1 was pi on 4, and I'm going to subtract the argument of z2. It was pi on 3. So when I subtract this, I'm going to have negative pi on 12. So that's the argument of z1 on z2. So also we know negative pi on 12 has as negative reciprocal 11 pi on 12. So that's it for question 2. So now in question 3, we're going to write the complex number z1 on z2 in algebraic form. What's the meaning of this? We know that the complex number z1 was given by -1 minus I, and the complex number z2 was half plus I root 3 on 2. So for us to be able to write this in algebraic form, we need to multiply up and down. We need to multiply by the conjugate of the denominator, and this means we'll simply multiply up and down by half minus I root 3 on 2, and the same thing, half minus I root 3 on 2. So now we are going to multiply top and bottom by the conjugate of the denominator in this way, and we're going to have that z1 on z2 in algebraic form is equal to 1 plus root 3 on 2, then plus I times 1 plus root 3 on 2. So this is the complex number in algebraic form. We go to number 4. Number 4 says we should deduce from the previous questions. We should deduce the exact value of deducing the exact value of the cos of 11 pi on 12 and the sine of 11 pi on 12. So remember, we said that the complex number z1 on z2, the argument of that thing was 11 pi on 12. So now, deducing the exact value, we can write that complex number z1 on z2 in the form e to the power I theta. So it means it will be re to the power I. It will be re. R is the modulus, which was root 2. Then e to the power I theta. Theta was 11 pi on 12, and this is the same as the modulus times sine theta plus I cos theta plus I sine theta. So I have cos theta cos of 11 pi on 12 plus I sine 11 pi on 12. So with this, we now see that the real part will correspond to the cos, and the imaginary part will correspond to the sine. Yeah, so it means that the cos of 11 pi on 12 is going to be 1 plus root 3 on 2. 1 plus root 3 on 2, and sine of 11 pi on 12 will also be equal to 1 plus root 3 on 2. So we have already deduced now the exact values of 11 pi on 12 and cos of 11 pi on 12 and the sine of 11 pi on 12, and here they are. So this ends the solution to exo 2.